Hello everyone, I am Kushal. Welcome back to my channel and today's subject is network analysis and the topic is superposition theorem. We're gonna discuss about superposition theorem. First, introduction to superposition theorem. Introduction to superposition theorem. In the field of electrical engineering, the superposition theorem is a powerful method used to simplify the analysis of complex linear circuit. It states that response voltage or current in any branch of a linear circuit is equal to the algebraic sum of the response caused by each source acting alone. Then definition of the superposition theorem. First principle. The superposition theorem states that in a linear circuit containing a multiple source that total current or a voltage in any given branch is the algebraic sum of the efforts produced by each individual source acting alone. And applications of the superposition theorem. The principle holds true for circuits with resistor, capacitor, inductors, and other linear current circuit elements. Then mathematical representation of superposition theorem. The superposition theorem can be mathematically represented by using the principle of linearity to simplify the analysis of the complex circuit. Then applications of superposition theorem in electrical circuits. First, first, the first applications of the superposition theorem we are using voltage source. Then voltage source. When analyzing a circuit with multiple voltage source, the application of the superposition theorem allows for an independent examination of each source contribute to the total voltage. Then current source. We can apply the current source to find out the superposition theorem in electronics or electrical circuits. Then current source. For a circuit containing a multiple current source, the superposition theorem facilitates the individual assignment of each source impact on the overall current flow in the circuits. Then third one, hybrid circuits. The theorem is equally applicable to the complex circuits with both voltage and the current source, providing a system and the approach for analysis and the problem solving. Let's move on to the steps of applying a superposition theorem. First step, identify the source. These are the steps of the solving the superposition theorem problems. Then first, identify the source. Identify all the independent source in the circuit including voltage and current. Next, second step, isolate source. Mathematically turn all but one source at a time while keeping the other active. Third one, calculate responses. Determine the response to each the individual source acting alone by the considering the related current and voltage in the circuit. Combine response. Algebraic sum the response obtained for each individual source to obtain the total response in this circuit. Let's move on to the limitations of the superposition theorem. Then there are three limitations are there. First one, non-linearity. The theorem is limited to linear circuit and cannot be directly applicable to non-linear elements such as diode and transistors. Next, complicity. In the circuit with numerous circuit and the components, the applicable of the superposition theorem may lead to extensive calculations and analysis. Then practically, real world applications may involve not ideal conditions and the interaction making it challenging to strictly apply the theorem in all scenarios. Then we can see some examples of using superposition theorem. First one, electronic devices. The superposition theorem is employed in analyzing and designing the electronic devices such as amplifier, filters and signal processing circuits and etc. Then another example in the power systems. In the field of the power system, the theorem aids the examining the behavior of interconnected electrical network under variable condition. Next, third one, control system. Control system analysis involving utilizing the superposition theorem to understand the impact of individual source on a system response and stability. Let's move on to the advantages of using superposition theorem. Next, what are the advantages of using superposition theorem? In simplicity, it offers a systematic approach to analyze a complex circuits by break down the contributes of individual source. Mathematically clarity. The theorem allows for a precise mathematical representation and calculation of individual source effects, aiding to accurate the circuit analysis. Then problem solving. By simplifying the circuit analysis, the theorem enables efficient problem solving and the identification of optical design strategies. Then, then finally conclusions and takeaways. The superposition theorem simplifies the circuit analysis and it is limited to linear circuits and independent source. Then applications include electronic power and control systems. Thank you.